Okay, so this is a video on functions in C++, specifically on something called pass by reference and pass by value. Certain other languages that I've played with, Python and Java, don't don't explicitly deal with this, at least if my memory serves correctly, or my experience with those languages didn't force the programmer to be aware of these things. And C++ doesn't necessarily either. Let's look at a function called do something, and it takes an integer and maybe it has a void return type, and it says cout a, and we call this function and we pass it the value a equal 5. Notice there's not going to be any name conflict here because the function, the variable a is defined, it's passed to this function as an input. There will be an error if I redeclare the integer variable a in this case, if I set the right, this error right here is unrelated because I have a different project set as my start project at the moment. But we see this redefinition error. Okay, you might think if we do this kind of thing, if we declare a variable a inside of the do something function and we also declare a variable named a inside the main function, that there will be a problem with that. There is no problem with that. Okay, just to point that out. That's kind of a side point, but I have an inclination to make lots of points. Probably too many points whenever I'm trying to demonstrate this thing called pass by value versus pass by reference. Okay, so if we call the do something function and we pass in the value a, nothing surprising is going to happen here. We will say print a in this function. If we increment a and we print the value before and after the incrementation, we see 5 and 6. But if we say the value of a in the main function, there is some question here, and it's a fairly interesting question to ponder. We had the value a is equal to 5. We passed it to the do something function. We printed 5, and then we added 1 to 5, printed 6. So I think maybe most people would imagine that the value of a in the main function is now 6. But it gets printed as 5. So this is called pass by value. Now, and also just to dig into a bit of detail here without hopefully overcomplicating, you can use you can use the symbol called the ampersand, and we can see something interesting here. The address of a in do something, the address of this variable in the do something function, you access this address of a variable by using the ampersand operator in C++. That's not to be confused with the double ampersand, which is called the logical and operator, oftentimes capitalized. And if you say 1 ampersand 2, this is actually, in this case, this is a binary operator. It takes two operands, 1 and 2, and it is a binary operator in this case, and it is called the bitwise AND operator. And that gets into thinking about numbers in binary like 0, 1, 0, bitwise 1, 1, 1, 1, 1. You can look into the meaning of this and it has some uses, but I'm not getting into it. Okay, but here, this is not the AND operator, the bitwise or the logical AND. It is called the address of operator, and we'll see what it does. It prints this hexadecimal 16 digits hexadecimal memory locations. So it's a memory address in the computer's RAM, or maybe if we're using what is called virtual memory, it's the hard drive. 16 digits because we're in 64-bit mode. If we change to 32-bit mode, we see 8 digits. 8 times 4 is 32. 1, 2, 3, 4, 5, 6, 7, 8. And the highest digit here is F, which has the value 15 in hexadecimal. So it's worth investigating perhaps what is the address of A in the main function. Perhaps we think these two addresses will be the same. And one ends in A7C and the other ends in 98A, and those are not the same addresses. And that's a critical point. Pass by value makes a copy of the variable A. And that also gets into what are called reference variables. If you say int ref, or we say copy of A equal A, and we say cout A and a tab and copy of A. We print both of these things, it will print 5 twice, which is not surprising. 5 with a tab in between it. 5 tab 5. Okay. But if we do an update to A and we say A equals 6, actually, is it should be clear at this point that this copy of A is what is called a shallow copy. Shallow. Oh, well, that's not clear, that this bit of jargon and terminology used in programming. But what I meant to say should be clear is this value right here is not going to be 6. We said A is equal to 5. This value, this variable holds that same value, which is 5. We set A equal to 6, so we're going to print 6 here. But we didn't do a second update here. We didn't say, oh, I need to update the copy and do this. We did not do that. So when we run this, we'll see 5 and 5, and then we update A6, and copy of A did not get updated. It's still set to 5. So 6 and 5, all right? But if I instead name this alias of A, and I say, and I declare this as what is called a reference type, okay, it has some special properties. It has a particularly special property, which I'm about to demonstrate right now. Okay, so now we see 6 and 6. So this is an example of a deep copy. This is can be used for deep copying, and deep versus shallow. So when we do an update to a variable and we've made a shallow copy, the updates won't get reflected in the copy. But if we do what is called a deep copy by using a reference variable, which is what alias of A is, we can achieve what is called deep copying. And whenever we update the original to 6, we will also see that this guy gets updated, the deep copy. So we see 5, 5, 6, 6. Okay. Maybe we're also curious about the addresses. We say ampersand A, ampersand alias of A, and put a tab between these. We see 2 addresses which are the same. Okay. And now we get to this thing called pass by reference. So let me remove some of this stuff. or prevent it from getting executed. So we're not looking at too much text here. Now, if we pass this variable by reference, this is called pass by reference. Passing by reference passes in the address of the variable A. And now we will initialize A to 5. We pass it, we say the address of A and main is whatever this address is going to be. You might think, can I predict what these addresses are? The addresses are, I think, determined by the operating system and Visual Studio. So you can't, maybe you could dig into it a bit, but to a first approximation, you can't know what the addresses will be. You can know what the variable A will be, what its value will be. We call do something A. We don't change this. We don't use this because that's not the correct data type for the input. We print the address and then we say A, which is 5. We add 1 to A. We get 6 here as the second line of output, or the third in this case. And we're curious now if the value of A in the main function will be 5 or 6. And let's see what we see. And this will essentially tell you it'll give a decent understanding of pass by value versus pass by reference. So we print the address of A in main is something ending in A4C. And then we call the do something function and pass it the value 5 by reference. Okay, so we say the address of A and do something is that same address. And that is because pass by reference passes in the address of the variable. Okay. We print A, we add 1 to that value, which is 5. We print 6 right here. Line number 12 corresponds to this line of output. And then we hit the end of the function definition, and we come back here and we say the value of A in the main function is, and it is now 6. Okay, so you can imagine that maybe this seems a bit silly, but I mean, I think it is. But if we instead return an integer from this function and we pass by value, we could say something like A++, and then we say return, we could say int b equal A, and now that's going to be 6, and then we could say return B. So this is a bit of a convoluted approach to just returning void and then passing by reference. And this will do something to A, and the changes that we applied to A will get updated in the main function as well. All right, so there are natural uses whenever you would want to pass by reference and pass by value. When we get to classes in the next semester or in future in these videos, a car class could include many different types, and it could be consisting of a number of attributes, like a string, brand, name. And if you pass by reference, that passes in the case of 32-bit addresses, you're passing in 4 bytes of data. The size of a car, not the literal size of a car in real life, but there's a potential computational performance benefit to passing in pass by reference versus pass by value, because the size of an integer, we say cout size of A, that is going to be typically, I mean, always in my experience, in my limited experience, it's going to be 4. An integer is allocated 4 bytes, whereas the size of a car, that is, how many bytes does this thing consume? It's actually a recent update to Visual Studio that shows you the size is 32 bytes. So think it should print 32 there. Yeah, it's 32. So if you pass by value, if you pass a car by value, you are passing in 32 bytes, which you're making a copy of the object. This is again called Programming Fundamentals 2, which I haven't talked about yet in this particular class, but this can be more expensive than this because the address, we say cout size of address of A and the address of a car object. Ah, interesting. I didn't know that that was. Okay, 32 bytes there. So if we make a car C and we say size of the address of C, we're going to see the same thing twice here. 4 and 4, 4 bytes and 4 bytes. If you change to 64-bit mode, you see 8 and 8. Okay, 8 bytes each. So there's a potential performance benefit if you pass by reference. But there are instances in which you would want to no good example that's within this class, Programming Fundamentals 1, occurs to me to demonstrate why you would want to pass by value int A like this. There are instances in which you're here in the main function and you don't want this value to be changed, but you just want to say cout A plus or something like this. You want to maybe see in the main function what happens if you add 1 to this variable, but you don't want the change to you don't want the change to actually be applied to the original variable. This is all not the easiest thing to explain because you just naturally, as you gain experience with programming, it might occur to you that on certain instances you would like to pass by reference and certain instances you would like to pass by value. Very commonly in the standard library code, that is this external dependency stuff, all these header files, you see const passing by const reference. And it is often advantageous to do this. Const prevents any modifications from A happening. You see, you can't add 1 because it's const. Okay. But this will become more clear to people as they gain experience with programming.